also, let me start with a question to the group. Is there anything in the lessons we've had to date or that you stumbled over that is like, what is this in the menu mean or do? And we'll hit that first, and otherwise, following that, then I'll just march through the menus.
I, for one, have questions every time I open the application, but I can't remember any of them right now.
Feel free to write them down and fire them in. So let me share a screen. And again, actually, this time I'm not going outside of the application, so I'll share the application. And are you seeing my application?
Yes.
Yep.
Yes.
Okay, cool. Okay, now somehow or other, I've lost faces, but that's okay. I'm used to losing face. Okay. There is a little menu up above, at least in the Mac version, and it's the sort of some of the standard stuff, starting new files, editing. There's a few basic visibility. The Viewcube is this thing over here that allows you to look at different views and orient them. The browser is this object right here, which is kind of a little bit of the structure of your project. Comments are down here. You can add comments, particularly when you save a version. So you can save comments with each version. Text commands we haven't really gotten into. It's a more of an advanced topic. I'm not going to go there. The navigation bar is this area down here that allows you to control certain things like orienting and zooming and grid behavior and display mode. The data panel is your data structure file management system, which is on Autodesk's cloud. So by default, your projects are all stored on their cloud. The advantage of that is it's backed up on the cloud. They can see it. It's not necessarily local unless you save it local. But you can also share it with people, and you can pull it up on your phone and other machines.
Tim, are those revisions on the side for between saves that you can go back to any version that you saved?
That's exactly correct. Yeah. So if we look at this canvas test here, we saved it a couple of times, and we see here item 1, it was saved at 637, and item number 2, or version number 2, was saved at 721. And you see the 3 dots, you pick on that, you can open it at that earlier level, or you can promote it to be the current primary version, or you can create a milestone, which is more of a documentation thing where you say, hey, this is my prototype for first production, first build, second build, production build, revisions, whatever sort of manufacturing control you have in there.
If you open an earlier version, does it wipe out, like, does it open it in a new screen?
Yes.
Or, okay, so you don't wipe out what you're already working on.
Correct. So you can open an earlier version. It'll open in a new screen, a new tab within Fusion 360, and then you can promote it if you want it to be the current one, or you can pull it up and look at it as you're making changes and just bounce back and forth between the tabs.
And how do you promote it?
It was in the 3 dots.
Oh.
Okay.
And Tim, above that it says history plus uses, used in, and drawings.
Okay.
Those?
Hang on just a second. Let me
Sure.
Let me rearrange my screens here so I can see you guys. Somehow every time I do this I get confused. Okay. There we go. Let's make this less than full screen. Pull it over to the other window. Okay. Sorry.
I was just trying to understand the UI that we were just talking about, because above it, there seem to be 3 tabs: history, uses, used in, and drawings. Just to the left of your cursor. Down.
Okay, yeah. So history, this is showing the different tabs. Uses, this is about parent-child relationships externally to the project. So for example, if I pulled a component I had previously designed in a different project into this project, then it would show up in this uses. Okay, let's say that I have a project up and it's in a, it's a complicated assembly of some kind. Let's see, do I have anything here? That was way earlier. Where's something with a bunch of versions? Probably in a different.
Hey, Tim, if it's not something that most of us would use, I don't want to sidetrack you too much. I was just wondering what it meant.
It could be. So let's say you have a complicated assembly. Let's go back to this project that I was working on a few weeks ago. And I have up to version 30 here, because obviously I did a lot of revisions on this guy. And it's coming down over the cloud at the same time that I think probably, oh, here we go, it's coming. If, for example, this magnet that I'm using on the side, which I've got turned off, if I brought this in from a different project, so I use it on project A, I go to project B, I want to reuse it, it would show up in here as uses, under uses. Okay?
So it's outbound uses in another project.
Yeah, so for example, there is one case here, and that's a different component, and I have it in its own place, and I've referenced it here. And used in is the opposite. So if this project is a subassembly that I then use in another assembly, it will show, hey, you're using this over there. So if I build a whole drive line here, and I use it in a car, when I come here, it's going to tell me which cars I've used it in. So I know that there's references back and forth, there's parent-child relationships that I need to be cognizant of. So I don't do something that breaks it. And then whether there's a drawing connected. So in this case, I hadn't done a drawing for this design.
Thank you.
You see, here is that other component that was showed up in uses. MMR is a magnet assembly.
So you should see used in here?
That's the uses. So this uses this magnet from somewhere else. Used in means this project is used in something else.
But would your next item on that list
same thing.
show used in?
Yeah. So if I came here,
Yeah.
for example, let me open this guy. And now when I'm looking at this guy, the magnet, and I say used in, it tells me that it's used in this other project.
Perfect.
Okay, so that's the parent-child relationships, the interconnectedness of all things, as Dirk gently would say.
Can you modify that? For instance, that magnet, can you modify it?
Yes, so
in all designs that it's used in?
yeah, so that's one of the things you have to be careful about when you modify things. So if I came into, that's a really good point. If I come into this magnet, and let's say just for the heck of it, I punch a new hole in here. And I'm just going to take the default size looks a bit big. Let's say 0.5 inches. Whoops, that's the depth. Let's change this size to 10 millimeters. And I've done something wrong here. What's going to let it be valid? Let's make a simple hole. There we go. Okay, we'll punch a hole through there. Now there's a hole in there. Now let's come back to here and see what happens. That's this window here. And let's enable this guy. And it isn't updated. Now, one of the things I didn't do here was save it. So let's see if I come back here, let me save this version. And user version is going to be, I'm just going to say test hole. And it's saving up to the cloud. And there may be some latency in all of this happening. But if I come back to this guy here, let me turn off the top and turn off my bracket. See the yellow caution sign? It says the component is out of date. So I have the choice to leave it out of date, because maybe I wanted to use the earlier version in this design.
You can break the linkage.
I can decide whether to update it or not. So if I want to update it, then I use get updates up here. And if I do that, it updates with the hole. So you need the ability to control that, because if I'm used an old component in one product, then I go to a new product and I modify it for the new product. Does the old product still use the old component or the new component? I need to be in control of that. So that's good feedback, good questions. Any other questions on the data pane?
Go ahead.
Go ahead, Travis. I'm going to ask about the other menus, but go ahead.
I was just going to ask about the people before we left this. Is this when your team is working together on something, collaboration?
Yeah, and so you can collaborate, and this is typical in the work environment. Not only do you need to collaborate with other people, but sometimes you have multiple people working on the actual same part, and so you have to be really careful about stepping on each other. More commonly, you'll have your own part within the assembly. So, as an example, when I worked on cell phones, the team might have 7 designers on the team, 7 engineers, or a combination of designers and engineers. And you had responsibility for various parts, but the assembly had to go together. And I'm working with a part that, Susan is also working on. And so when she checks in her part, I need to make sure mine still fits with it. And so having a data management system that works on a team basis is really important, that manages revision control and documentation and all that kind of stuff. Now, one of the things we've toyed with here, and I haven't really focused on it yet or really worked out how to do it, is how to share these teams. I should be able to share with you as a team so that you can pull down parts or projects and do homework with it, or put your projects up for me to look at when you have questions. So it's one of the big advantages, and the fact that it's on the cloud makes it really easy. And so you can bring it up on different computers, multiple computers. There's an app for the phone, which I think is primarily just a viewing app, because you don't really want to be doing 3D design on a phone, I don't think. But it's kind of cool that you have that, because then you can take your design and show it to somebody. Or you can pull it up on a different computer to do a presentation in the office if we ever go back to working in offices. Yeah, so that's kind of the data interface, data panel. It's pretty cool. It's pretty powerful. It's neat that with a hobbyist tool you have this level of cloud management, version control, documentation, teaming, all that stuff.
Yeah.
I've got a question. When you do your design on each project, in the past, setting up parameters. Similar names have been used each project we go through. So is that name unique to that particular drawing and somehow known in the computer, or do you have to use a different parameter name on each project if you're going to blend them?
That's a really key question, because you need to understand whether parameters are global or local. Within Fusion 360, I have not seen a way to make parameters global. They're restricted within the project that you're defining them in. So you can use length, width, depth in each different project. That having been said, it's a good practice for your names to be as unambiguous as possible. So length, width, and depth on their own are kind of bad names. But, you know, magnet depth, magnet width, magnet height would be good. Cabinet width. Those kinds of, use names that are specific enough. It's a little bit like, you know, coding software. So I'm not sure if it's only Nancy who has this experience, but you want to use variable names and documentation, commenting, so that when you come back to it 8 months from now to make changes and you haven't even looked at it in 8 months, that you can look at it and remember what it was. You know, it's one thing when you're working on it. Hey, I can get away with D1, D2, D3. I can probably figure out what they are. But a year from now, when something breaks, someone has a question, I got to go back to it. Can I figure it out? Or when I go back to do a new revision. So try and make it as user-friendly as possible. So use parameter names that are better than the ones I was using. Use parameter names that really describe what it does. It's tempting, and I fall for it. Use the quick and dirty, short and simple ones, or don't use parameters. And you know, often that comes back to bite you in the future.
So Tim, on this magnet, do you have parameters in the parameter table for the magnet? Does it pull it in, and does it identify it that it where it came from or anything?
If I had designed this magnet from scratch in Fusion 360, it would. In this case, I actually imported it from either from the vendor's website. Actually, I'm pretty sure it was from the vendor's website. So in this case, I downloaded a step file from the vendor's website and read it in. So it's automatically scaled. There are no parameters. There's no history. If I look at this device, if I make it, can I make it can I even make it active? I don't think I can even make it the lead. At least not in this window. Maybe in this window I can. Yeah. So if I look at what's here, it shows me the individual components, but notice there's no timeline here. The reason there's no timeline here is because there are no sketches, bodies, features. They are single imported elements.
Hey, Tim, you said that this was brought in as a step file. And I remember that the greater assembly you were showing us was something that I believe you had designed for a previous employer or something like that. But you didn't do it in Fusion 360, if I'm right. You did it in something else and saved it as probably a step file. How good is Fusion 360 at accepting that's a standard interchange file format like that and not leaving a lot of things on the sides? Does it do a good swallowing of a standard file for a project?
That's a good point, because historically there's problems with it. I haven't run into problems with step files importing into Fusion 360 or pretty much any other package. The step file translation seems to be quite solid. IGES files, I've run into odd things. A little bit like you sometimes run into with STL files where a seam is open.
Yeah.
and the mesh isn't properly closed. But step file actually uses a solid file definition, a solid part definition. And I have not seen a lot of trouble. I've not run into trouble myself. What I have seen happen in the distant past is giving a very complicated component to somebody who's making the tool, and they have trouble importing it into their CAM package. But I've not run into CAD problems with step files. Step file is very robust.
And it is a thing. There is no history that comes along with it. A step file is the final version of something.
Correct. So it can be an assembly and you have multiple parts. That's what this was.
Yeah.
These names, none-464, those are automatically produced by the importer as it brings them in. And yeah, I have not had a problem with it.
Okay.
So if you import a file from somewhere else and a parametric variable is named the same as what you are bringing it into, does it notify you that, hey, you got a same name that's referencing two different variables parametrically?
That's an interesting one. So when you bring in a step file, there are no parameters that come in. But where you run into that is if you would bring a Fusion 360 subassembly into your new assembly,
Right.
what happens?
Yeah.
And I think what you're going to see is that the initial parameter is local. That's a really good question, Paul. I like that question. I'm going to play with that offline and see if I can break it.
Yeah, because like you said before, width is a very generic term as opposed to bracket width versus magnet width is very project specific. So, okay, yeah, just wondering. Thanks.
No, that's a really good one.
Hey, Tim, I don't know if you have your chat box open, but Jim had a question for you. Would you like us to just interrupt as Travis is prone to do, or do you want us to use the chat window?
Actually, let me see. Sometimes I see the chat window, and sometimes once I've got the screen share up, oh, there we go. There's a chat window. Generally, I prefer just that you interrupt me.
Okay.
Because I'm not always seeing the chat window here. Let me move the chat over here.
It's just the last item in the chat.
And yes, Jim, the answer is yes. And from MasterCard, it's particularly simple because it's right here. It's in the insert menu. You go insert MasterCard component. You go to the menu. Hey, I want a screw or a bolt, socket head screws. I want metric. I want something that's an M8. And just like you find everything else, let's grab this guy here. Go to product detail. Scroll down to the bottom. And I'm going to bring it in as a step file. And boom, there it is.
Amazing.
It's incredible. You know, it's cool that they've linked it with MasterCard. You can bring any other one in, but usually you have to go to the website, download it to your computer, and then upload it into the, insert it here. But with MasterCard, it's actually got a link to the to the catalog. Fusion 360 provides APIs so people can do this kind of thing.
Was this a setup question? Because it looks like the threading of the hole you made that was supposedly arbitrary is the same as the bolt you just brought in.
That's pure coincidence. honest. So, but while we've got it, then let's, oh, come on. Let me rotate it. Oh, I guess I accidentally saved it or something. Yeah, so here it is. I'd have to go in and redefine it and move it around. But yeah, it's kind of cool.
Totally.
Anything else on these subjects?
That's a great feature. I really like it.
Yeah, same here. I love it. And I'm, I'm a fan of McMaster-Carr. I ordered some I was looking at the bolts that were used on the guide wheels on the Ortour Laser and decided I wanted better bolts. So I ordered some from McMaster-Carr and they arrived today. I ordered them on Saturday. It's awesome.
Yeah.
I like McMaster-Carr and I like the fact that they're integrated like this. Okay, moving on through the menu. So we kind of started with this top menu a little bit.
Tim, I just want to back up a little bit. What is that bolt called? Does it have this cryptic McMaster part number, or is there any kind of a descriptor once it's inserted into Fusion?
So by default, it's coming in with McMaster-Carr part number. But like any other app, you can rename it to what you want. So this is like M8 by, I'm gonna look at that and say 15. X socket screw.
Okay, good, thank you.
Yeah, so. Yeah, and same thing here, this could be, I can rename this to be, spacer, and, oh, that's the other spacer, and this is the actual ceramic magnet bar. Whoops, I was highlighted in the wrong place, and then a whole bunch of, quick keys jumped in, but that's the idea. Come on, let's go back here. Yeah.
So when you rename it, if you do like an assembly bill of materials on this thing, is it still going to retain the McMaster-Carr part number, or the one that you reassigned and now you have a lost correlation?
Well, that's a good point. It'll use the one that I've put in here. But if you remember when we had drawings, that we had a description file, a description column in the parts list.
Right.
And so what I would tend to do is I would tend to leave the McMaster-Carr part number as the file name. Unless I needed a generic name for it. Let's see, where's a drawing? Do we have a drawing? Do we save any drawings? I guess we didn't. I don't have any drawings here. But in the drawing part list, there's a column for the name, or part number it calls it, and for description. So instead of changing the name, I would actually go in and change the description and put the M8 by 15 hex socket screw in the description, so that my parts list looks like a good parts list and I can go straight in order on it.
Okay.
Now in a lot of, particularly larger, medium to large size companies, you're going to have your own internal part number for everything so that you can have multiple sources. So instead of the McMaster-Carr part number, it's going to be the your own company's part number, that somewhere you have a system that documents who your approved vendors and parts are, etc.
Right, with equivalent substitute or equivalent, substitute manufactured part numbers that will work. Yeah.
Right,
okay.
right. So that's a typical way there. Okay, and I think most of us have seen, I'll just quickly zoom through, this is the browser, which is kind of the structure of your project. It includes your sketches, your components, your assemblies, analyses, sort of things you do. If you have a component or an assembly that has a lot of history that you've stored, then you have a timeline down here, and you can move earlier or later in the timeline, make changes, go back into history. It's quite powerful. We had a good little demo last week from who was it? That was it Jim that had the demo of going, Jim or Paul, sticking.
Oh, the guy who had the table that made the legs, right?
Right.
Yeah.
That was me, Bruce.
Bruce, good.
Yeah, Bruce, thanks. And moving things back into the timeline to get the behavior that you want when you want to customize one of the 4 legs, or you actually want it to propagate through the mirrors. So it's that's the timeline for you.
I have a question about that.
Mm-hmm.
So each one is an action. Like I know with the sketch, there's complete sketch or finished sketch or something like that. But is the only way you get to the next one is just do a different action and extrude something? Well, sometimes I feel like I'm in the same one for a long time.
Well, you're in the same element on the timeline?
Exactly. Like I make a lot of changes in one element where I would rather have it be separate, you know what I mean?
Yeah.
So,
yeah.
Yeah, so maybe you're putting all your detail into the sketch.
Could be.
So what I'll often do is I would rather make a simple sketch and then add functionality that's easier to change. So, you know, one of my examples is I would rather create, you know, a box and then finish that. Now I'm going to put a hole in it and finish that. And then I'm going to put a fillet on the corners and make it, etc. So there you go. I have 3 features, and except for the thread, I could have done all those in one sketch and one extrusion, right?
Right, and I think that's my problem is I do that, and then I can't really, the granularity is lost, and yeah.
Because it's like one massive, you spend so much time making a sketch.
Yeah.
So it's very involved. Not until you say finish sketch do you actually get something to show up on your timeline.
Right.
Right? Is that what you're saying, Nancy?
Yeah.
Yeah, that's what I find too. I put a ton of time into something. I've made like one little icon at the bottom.
Yeah, no. You know, I'll, you know, again here, maybe I want to groove down this thing. I'll still create this thing first. I'll come along and go, okay, I want to groove. I'll do a whole bunch of features in this that could all be in one sketch and one extrude. But my design intent is that those all have specific functional reasons for existing. So the overall body, I'm designing it to fit into something. Then there's a groove or a slot. Hey, it's to go do something else. Fillets I often leave till a little bit later to simplify things. And then it's easier to find them and edit them. You can you know, find your hole. Now it's highlighted. Boom, I can edit the feature and go, yeah, you know what? I didn't want threads in there after all. Let's just make that a straight hole.
So it's just about thinking about your actions, your design intent, as you're saying. I don't think I think about that very much.
Yeah, and that comes with practice. That comes with time.
Yeah.
But I think of a one basic big extrusion that is kind of like the base feature of my part, and then everything else is things that I do to it to get to where I want to be. Okay. Now we've talked a bit about sketching, but let's pop through the sketch menu. So we create a sketch, and what are all the different options that we have in the sketch menu? So I think we've all learned the line and arc, so we can do a line. This is all single click stuff. If you do if you hold and drag, you're going to get a tangent arc, so an arc that is tangent from the point it just left the line of. And then when you get to the end, you double click, and then your line arc is complete and you're ready to go do another one or do something else. You can also hit the escape key, and that takes you out of the command.
When you said hold, did you mean hold your mouse button down?
Hold the mouse button down, yes.
Okay.
So generally with Fusion 360, it's sort of a click, not a click and drag. That's one of the exceptions. So click, move to make a line, click, another point, click, another point, but click and hold and drag gives me the arc. And then a click finishes it. And here's another line. If I go way off, it'll be non-tangent. If I'm close to tangent, it'll snap to tangent. And then I'll double click on my endpoint, and then I'm done.
Oh, double click on the endpoint just stops the drawing.
To stop the chaining of the line.
Okay.
Mostly relevant on this tool. Within rectangle, we have the 2-point rectangle, 3-point rectangle, center rectangle. So 2-point rectangle from here to here. That's pretty straightforward. Center rectangle, particularly when you're doing symmetry, I like that one. I'll click on the origin and then one of the corners. And then the 3-point rectangle, you'll define a point. You'll define another point, defines one side of it, and then the other side of it. So kind of depends. Sometimes that's relevant because you're clicking onto existing things in your design.
So if you want to verify what your sketch plane you're on here, you just look up to the cube up there, and that shows you that you're on the what, X, Y?
In this case, yeah. In this case, I'm on the X, Y, which is from a top view.
So if you had projected something, what's going to happen?
Well, if I projected something parallel to top, it would still look like top. But when I go to the isometric view, then I might see the difference.
Then you could, for example, look at the front and see if they're off plane.
Right. And in fact, when you finish sketch, yeah, from the front, if you look from the front, they're all on plane. Right? Now, the other thing is, one of the things you can do, you have a sketch here, when you go to edit, you can redefine the sketch plane. And if you pick a different sketch plane, it's going to reorient it and move it to that sketch plane. Now we're on the XZ, or front plane, because we redefined it.
Now, if you followed through and you took your sketch and you extruded and made a piece, and then you went back to the sketch and redefined the sketch plane, would everything move?
Good question. Let's demo it. So let's do an extrusion using this guy here. We're going to take it in that direction there. We're going to say OK. Now we're going to come back. Remember, this is a parent, this is the child. So what's going to happen if we redefine sketch plane to be this, it should do exactly that. So now let's show the sketch again so we can see what happened there. And the answer is yes. So when you change a parent, the change will translate through to the child. There may be times you break something doing that. That isn't one of them, but there may be times when you make a change and it breaks a child. A child no longer can be defined, and then you'll get an error message and a highlight on the feature that's broken. Okay, back to our sketching. Let's just get rid of this feature here. And let's edit our sketch since we're just messing around in here. Similarly, circles, different ways to define circles. Center, diameter, most common. 2 points. If I pick a 2-point circle and here's my 1 point and here's another point, it's going to make a circle that define my diameter. But if I make a 3-point circle or a 3-point circle, then it's going to be, I could pick this point, and a third point to define that circle. Okay, let's just get rid of a few things here. It's getting a little cluttered.
Hey, Tim.
Yep.
As a general rule in Fusion, are there any things like you have certain keys that will alter the function? So for instance, if you were in a lot of typical Windows drawing packages and you choose an ellipse, you'll get an ellipse based on how you're dragging it. But if you were to limit it with, say, I think it's the Shift key or the Control key, it will only be a circle. Those kinds of constraining effects that a button in conjunction with the mouse will do. Are there things like that, or does this not behave that way?
There are some, but not as many as you're used to. So for example, you asked the question on the canvas last week about whether when I'm scaling the canvas, I can make my 2 points be restricted to be co-horizontal.
Yes.
And I could not find a way to do that.
Okay. But there are times when you can.
There are times when you can.
Okay.
I'm blanking on exactly where they are right now. But
Well, that might by itself indicate how rare it is. So I think maybe in general you don't see that here, huh?
not as often, no. And then if you go to tangent, for example, 3 tangent circle, how about it's tangent to this, and it's not going to want to be tangent to that. Can it be tangent to this? That didn't work, did it? Or did it create this one right here? Yes, it created this one right here. So it's tangent to this, and tangent to this.
Oh my gosh. Yeah,
Right.
You're right.
So, and you'll do that using existing geometry. If I pick these 3 here, there's my circle.
There was an actual menu selection for this crazy thing?
Yep. So under Create Circle, you have 5 different ways to define your circle.
Oh my gosh.
And again, this is parametric. It's follow your design intent. How are you sizing and locating the circle? If you're doing it on the basis of being being tangent to something already in your design, then use it.
Yeah.
Because you're building your design intent into your top level of your part,
Wow.
component, your design. Similar with arcs, you can define an arc with 3 points, beginning, end, and then somewhere in the middle. You can create an arc using a center. So let's say I want the center to be here, and I'm going to come out, and here's 1 point of my arc, and here's another point of my arc. That's an easy way to define it. Tangent arc is, and again, we saw this with the line mode, we can make it tangent to an existing line. And then we just find the second point. That's arcs. Any questions on those basic elements so far?
I have a question that's kind of related to drawing. Hypothetically, what if you over-constrained your drawing and it gave you that error? And how does it help? Can you do an example of that? Like, how would you fix it?
Yeah, good one.
Yeah, that's good question. Over-constrained drawing. Let's, come on. Let's turn the origin on so I can grab it. No, I didn't grab it. That was just that dimension. So You know what? I'm going to get rid of a couple of these big guys. I think they're eating up a lot of bandwidth. Come back here. Let's dimension. So we got this guy dimensioned. Let's dimension this guy. We have parallels. Let's say I try and dimension. Oops. Complete the dimension. Let's dimension this angle here. Okay, adding this dimension will over-constrain the sketch. Choose OK to create a driven dimension. So my option, it will not allow me to truly over-constrain it.
Mm-hmm.
What it'll do is I can either cancel or I can create a driven dimension. If I create a driven dimension, you'll see the dimension is in brackets.
Yeah.
And what that means is I can't change this value. It's the result of other things happening. Now, if I wanted this to drive it, what I would need to do is get rid of some of the other constraints that are limiting it. So let me go to select. Let me pick this constraint.
Was the indicator that it was a driven constraint, the fact that it was in parens?
Correct, in parentheses, that's
Okay.
correct, yeah. Now if I delete some of the other constraints, oops, that wasn't what I wanted. I think I gotta go this way. Now, it doesn't look like it converts it. Toggle driving. Now it's a driving dimension. Now I can click on it and change the value.
How did you get that toggle?
I right-clicked on it.
Okay.
And I first removed the other constraints that would have made it double.
Right. You couldn't have made it that unless it was free to do so.
Yeah. Yeah. Now this failed to solve because there's too much craziness going on. I've got a lot of nonsense here. I'm actually going to just.
Now you've got an X down there and a triangle in the corner. So that's because of that, what you just did.
Yeah. So I said change this to 110 degrees, and they're like, "What the heck happens to the rest of the world?"
And what happens if you click on the? Oh well, you.
Oh, sorry.
got rid of it now.
The X and the
The little
exclamation
X,
mark.
yeah, down there in the corner, in the right corner.
Let me do the 110, and it's going to sit there, spin some nice colors for me, and then come back and complain. I'm getting frog noises somewhere. I'm not sure if that's F360 or somebody's pet.
Or did everybody have dinner?
That's my cat. Sorry.
Ah,
I thought it sounded like something breathing, a cat or something. Yeah, yeah.
That's the second cat I've seen
yeah,
today.
I think Wes had one too.
Yeah, I've locked mine out of the room. So if you hit the X, it just tells you failed to solve. Please delete or modify one of the following constraints dimensions, and then there are none in the following list. So it's not entirely useful. And then if you hit, this one is something else. It's just telling me that I'm having performance issues, and that's probably because I have too much going on. Probably we're streaming here. I think the cats are probably watching their RuPaul's Drag Race or something, and then we have
You're right.
Okay, so back to the driven and undriven, or
driven and driving.
Yeah, whatever. Driven and driving. When it was 90 degrees, because it was driven, you couldn't change it. They were just showing you the dimension, basically.
Correct.
And saying there's nothing you can do about it. And then you got rid of one of the constraints, and then you made it a driver and made it any degrees you want.
Right.
Gotcha. Okay, cool. Thank you.
You're welcome. No, these are good questions. And I know, like, this is kind of beginner night, but most of you are beyond that. So If I'm getting too much into the weeds, then you guys pull me with better questions.
This is great.
Polygons, there's 3 different ways to define polygons. Circumscribed, so circumscribed means the polygon's on the outside of the circle and we're defining the radius of the circle. And so we can define a size, type 80, we tab, we can say how many faces, how about 9? There we go. So that's one way to define a polygon. The other one is inscribed. Inscribed is the opposite, where now it's on the inside of the circle. Polygon is inside the circle. And then you can also define a polygon.
When you did that, Tim, could you have kind of done a shift key or something to keep that line horizontal? Because it's not quite horizontal.
It's not horizontal. Let's try that. Inscribed polygon. Let's go like this. Does shift do it? Shift doesn't do it. Does control do it? Control doesn't do it. Does Win do it, or Apple key? No, doesn't do it. Does Alt? Nope.
And then there are the combinations.
Just some
there is a snap. There is a
snap, I guess.
Yeah, there. No, these. What's it? Oh, this is a snapping to the grid.
Yeah.
This is just snapping to the grid. Can I here? Nope. There's nothing on the marker menu for me. So yeah, I don't see a way to particularly do that.
Okay.
Now
you're a man after my own heart.
Yeah, no, it's a good question. It should be there, and perhaps there's maybe it's a combination of keys that I haven't found yet. So I should go looking for it. And then the edge polygon. I mean, basically, maybe you want to use something that's already there. You define an edge, and then put my polygon over here. In this case, I want to have 13 sides to my polygon, and there I go. And just define which side it's on this way. Okay, and I'm just going to back out a couple of these so that my palette doesn't get too crowded here. Ellipses. Ellipses are pretty straightforward. As far as I know, there's only one command for the ellipse. You hit with the center and then the one of the radii and then the other. So whichever of the radii are larger is the major axis and the minor axis. And this creates an ellipse, which are fun, not an oval. And following that is the slot. Now the slot is where you get something that's oval. So you can define a slot as center to center. This is typically when you do like a bolt slot, and you define your center to center and then your width dimension. There's a number of different kinds of slots. You can define the dimensions overall. So you're going from the edge to the edge and then the width. One of the fun things is you can do, and a center point as well, you can figure that one out, is an arc slot. So if we do a 3-point arc slot, we can do something like, whoops, something happened wrong there. What did I do? Create slot. Oh, center point, 3-point arc I meant to get. So 1 point here, 1 point here, 1 point here, and then my width. Does that remind you of anything?
The arc. The tray.
The tray.
You could have done this for your tray.
But really, you had the same 3-point construction that you had with the arc. You just added an additional point, which was the width of the ellipse around it, right? Or the slot around it.
The slot around it, yeah. And while I'm here, I'm just going to show you a couple things. So I'm going to jump past a couple here and go to point, sketch point. So sketch point is kind of like, you know, one of those datum things. I'm going to put this sketch point right at this midpoint. And the sketch point is a point you can define in your sketch to use again elsewhere. And remember, we had the whole discussion last week about anchoring the sweep profile to the sweep path. This is one way to do it. So I'm going to just finish this sketch. And then I'm going to construct an offset plane. And instead of distance, I'm going to say to object, and I'm going to pick this sketch point and say, okay. So now I have an offset plane parallel to the XZ plane.
Z, yeah.
Or YZ plane. And this would be the plane on which I would want to sketch a profile. So what I'm going to do is I'm going to sketch a profile on this plane. And see, I have this sketch point here. Now what I'm going to sketch here is I'm going to sketch an arc using the center point arc we've discovered before. And I'm going to use that as the center and use this point here, come down like this. And then I'm going to change to a line, and I'm going to create a line like this. And
like which one of those is our reference point again?
The reference point here was that sketch point.
Okay, good.
All right. Okay, so now one of the things, let's look at sketch 1 and edit it because I didn't properly put dimensions in there or parameters. So let's dimension here to here, and let's make this 10. Okay, I'm going to finish this sketch, and I'm going to edit this sketch. I think I already made that one 5, right? Edit sketch. Let's see, I did it by default, but let's put a, you know what's happening. You guys see this coming, don't you?
Yeah, yeah.
Oh.
Yep, 5 it is. Finish sketch. Now I'm going to come up here and I'm going to demonstrate the sweep function.
Wow.
And I'll come back to this, but let's do a sweep function. And for the profile,
but you didn't have to do a slot to do a sweep. You could do a sweep on an arc, right?
correct. This one.
But here he's going to get that.
The path is closed here. It doesn't need to be. That's just coincidence.
But the beauty of what you're about to do is you get the end structure as well, which we had to do distinctly when we were working on the tray, right?
Correct. Now, in this case, it's going to be a solid, but that's the groove.
Yeah.
The negative of that is the cracker groove. Yet another way to create the same geometry.
Yeah, how many ways can you skin a cat?
Exactly. Hey, easy, there's cats listening.
That was pretty cool.
Yeah, so yeah, I kind of wanted to show that. So back to sketching. Let's do another sketch over here. What other tools do we have in Sketch that we haven't talked about? We did the slots. Splines, there's two kinds of splines. Splines like polynomial curve fit basically. And this, in this case, the curve must go through the points. But when you finish, it gives you these angle control as well. So now you can come in here and you can alter the shape of your curve.
Can you lengthen and shorten those as well?
You can grab it and pull it in.
No, I meant the handles.
Oh, the handles? Yes.
Okay, okay.
You pulled on one handle.
Well, actually, when I'm pulling them, it's having an effect.
You pulled on one handle and it changed the handles on both sides of that point. Is there a way just to change the handle on only one side of that point?
Not sure. Has anyone done this?
In Adobe Illustrator, you can.
Yeah.
Yeah, I'm not aware because here it's affecting the mathematical definition of the line as well. You see it flatten out.
Right. It does when you can control the individual handles separately as well. I mean, you're just altering the line in a different way.
Right.
It does some odd things when you try and offset that polyline. Because I tried that on something else and I got some very weird geometry as a result of offsetting polylines.
Oh yeah, he's getting a point there. Yeah, cool.
Yeah, the definition starts to get a little weird when you go beyond negative radii.
Yeah, you did that in an offset on the tray, right?
Yeah, yeah.
I tried to. Yeah.
Now another way to define a, let's get rid of this just so it's out of the way. Whoops, I didn't mean to go back that far. The other spline is control point spline. This is kind of like a best fits, where the line doesn't actually go through the points themselves.
Oh, okay.
But now you can modify, whoops, that's creating a new one. That's not what I wanted. Select, now I can move it around, sort of like curve fitting.
Yeah.
Polynomial where you're using a lower order polynomial than the number of points or something like that. If I could remember algebra from, we won't say how many decades ago.
1,000 years ago?
Yeah, something like that. That was spline. Any questions, spline? Conic curves are curves you make that are kind of like arcs, but not really. There's a different definition to them. There's the, y to the third, and then they have a value of rho. And if you use 0.414, then it's a true, it follows the definition of an ellipse. If you use a different number, it does different things. So like, and I think 1 is the highest. If you go to 0.9, it makes it very sharp. If you go to 0.1, it makes it very flat. So you can kind of control this. Different kinds of things you can do with Conic, getting into more esoteric curve shapes.
Yeah.
The point we did, text is simple, it just inserts text. And you have the ability to
I'm looking at the fields there though, and I don't see where perhaps you can do centering or right justified. I'm just curious if that sort of thing is possible.
No, it's very simple. It's very basic.
Okay.
And some fonts will do italics, some won't. So,
Right.
For example, if you come down and find something more interesting, chances are it doesn't do italics or bold.
Is it picking up your computer fonts, or do you have, it only has the ones that are included in Fusion?
As far as I know, they're included in Fusion. I haven't investigated importing fonts. That's a good one, because what I don't see is like drafting fonts or anything like that, which are kind of obsolete, I guess. But and then the angle. Let's do 45. You can do an angle. Another thing you can do horizontal flip, so you can be backwards. For example, if you want to etch this onto the back of a clear or mirror acrylic or something like that, you can do that, all that fun stuff.
Are there any handles on the box surrounding the text? Or is it really just...
No, let's go back to select here and see what we can do with it.
Okay, so you can stretch, okay?
Yeah, it looks like we can. Can we stretch it straight down? It's not changing the aspect ratio of the text.
Right. That seems locked, yeah.
Yeah.
Cool.
Okay, so that's text. And then, of course, you can extrude the text and do all that kind of good stuff. I'm just going to hit delete here and get rid of some of this noise.
They're still fonts, though. They're not curves at that point, right?
They are fonts, but you can extrude them.
Okay.
So they kind of do act like curves. So if we create text here and we...
I see that text is Arial. There was a box there, so I think you can change the font.
Yeah, you can change the font.
But you're saying the list is not the system fonts, but the Fusion 360 fonts.
I believe it's the Fusion 360 fonts. I'm not entirely sure.
Actually, it was looking at my font library for a specialty font, and it found it. So I think it's using a Windows font.
That's interesting.
Familiar,
yeah, I didn't dig into that because that's really useful because then you can get all kinds of fonts.
Yeah.
Yep.
So if we finish the sketch, do an extrude.
All right.
We can extrude that and 3D print it or do whatever it is we'd like to do with it. It's pretty cool.
Yep.
Oops. We're out of sketching. Let's create a sketch. Let's go back to this plane here just for the heck of it. See what other fit curves to mesh section we won't get into. That's a little bit more advanced. Mirror we've used. So if you have objects, any kinds of objects in your sketch, and you can mirror them about any line that's in your sketch. So for example, I can select this, say mirror, I could mirror it about this line. Whoops, I didn't mean to need to select it as mirror line. I can select about this one, or I can select an existing line somewhere else in my part.
Okay.
Any one of these.
Hey, Tim, back in the menu where you could choose mirror, there was an ellipse on the right-hand side of the menu. What was going to be revealed there? If you go down to mirror, go down in the menu there. Sorry, under the create menu. Yeah.
Oh.
There's an ellipse there on the right. It implies more functionality. What is on the right-hand side there? Just of about an inch to the right.
Inch to the right.
Inside of the menu structure, though.
This one?
No, I'm sorry. Go down about 6 items to the word mirror.
Mirror.
And then notice that there on the right-hand side is a vertical ellipse, 3 dots.
Oh. This is on all the commands. You can pin it to the toolbar so that it's there, which it already is.
Got it.
You can pin it to your shortcuts, and you can give it a keyboard shortcut. So say you use mirror a lot, you could use M for mirror. Right now, M probably does something else. I'm not sure what. But.
Okay, good. Thank you.
Is that what you did to get the sketch palette over there on the right? Pinned it to the somehow?
The sketch palette comes up automatically when you sketch.
Oh, okay.
But you'll notice here under line, see the L? That means anytime you want, if you're here, you just hit the key L, you go into line mode. I haven't really pushed the shortcuts because it's hard to follow shortcuts when you're teaching somebody over Zoom.
Right.
Can I ask you a quick question about shortcuts? This has been on my mind for some time.
Go for it.
To get to get to the panning tool or the, what's the other one called? The rotate tool. Are there keyboard shortcuts for those?
Well, orbit.
Orbit, that's what I meant.
Yeah, orbit is what they call it. Yeah, and everybody calls it something different. If you hit the shift key and use the middle mouse,
Yeah.
you get orbit.
What about if you have a Mac that doesn't have a middle mouse button?
Then you go to
Best Buy.
Amazon, you buy a three button mouse.
I don't even like using Fusion if I don't have a 3-button mouse.
Your
Drives me
life
nuts.
will be so much easier
Yes.
if you get a 3-button mouse with
Uh,
a scroll wheel.
with a scroll
Absolutely.
wheel.
Yes.
Right.
Look at the zooming in and out, right? So to pan, I often go like this. I mean, you can also, let's see what happened. It's a center mouse button. If you just hold the wheel down, it pans.
If you have a wheel.
If you have a wheel. Hey, don't reinvent the wheel, but buy one.
There were two more items about the bottom of the crate. They were like making a grid of stuff. Circular pattern and a rectangular pattern. I used the circular pattern to put some screw holes on like a heat sink that was a round disc, and I wanted some couple screw holes to bolt it onto something, and I used that circular pattern, but it wasn't quite obvious how it worked.
Okay, well let's come to our sketch here. Let me get rid of a couple guys here. We'll leave the square here though. I'm gonna hit the delete key. I'm gonna leave this square here. And what I'm gonna do is I'm gonna create a circular pattern. Objects, I'll select, well, maybe I'll select them all, not just those two. Well, that's interesting. Come on. Okay, toggling. I'm going to create a circular pattern. Those are my objects selected. I think that's 4 lines and 4 points.
Oh.
And my center point, I'm going to pick, let me pick this point here. It's not. Pick this point here. And there's my circular pattern. Now, one of the things I like about circular patterns is, for circular patterns, often is something you want to do in a squarish design. You don't think of a circular pattern, but it's actually a circular pattern. And it's quicker and easier sometimes, and easier to define than a rectangular pattern. But this is a circular pattern.
Is it on the plane of the original object, or does it have
It's on
to
the
be
plane
say
of the sketch plane. We're in sketch mode.
Okay, so whatever plane that was, okay.
So we're actually on the front plane. Yeah.
Got it.
Okay.
But Tim, it looked like the rectangles also rotated as you created more and more instances of it. Is there a way to keep, let's say, those duplicate rectangles all orthogonal?
Let's create a circular pattern with the center point. Let's grab this center point. Type full, type angle, type symmetric. So this is if you want to do less than a full circle. You can either do one side. Let's say, for example, we did an angle, and where's the angle definition? Oh, here it is. So we can pull it up, and there's our 3. Or we can make it symmetric, so one on either side in this case. Suppress gives us the ability to turn any one of them on or off.
Wow.
So, for example, if we had gone with 7, let's make a whole bunch more of these. See, this one is turned off.
Yeah.
So you can make a less than full circular if you want. It does rotate in a circular pattern. Generally,
Actually, there's more if you scroll down. There's more.
yes, there is. Oh, here's the total angle. That's what I was.
Oh, there you go. Okay.
Total angle.
Your point.
180. Let's make this like 110, and it's going to pull them all up into that. Oops.
But you can't stop them from rotating.
Doesn't look like it.
I don't see a way to do that in a circular pattern. Kind
I
of.
would think you could grab all of them and then make them, change their orientation, right? Can't they all be rotated, or are they all kind of fixed among that point?
I think they're stuck.
I think the answer is to always use circles myself.
Yeah. Now, the other thing, of course, is the rectangular pattern. In the rectangular pattern, they maintain their original orientation.
Right. It's an array. Yeah.
Right. It's an array. Yeah. That's exactly it. So in this case, let's the rectangular pattern. This time, we're just going to do a pattern of these guys. We're going to offset in this direction by that many and have 5 of them. And then we're going to do in this direction, and we're going to do 3 of them.
And you can uncheck the boxes again.
And you can uncheck the boxes again, exactly, right? So an interesting one for this one would be, if I see, can I edit the pattern again? How do I edit?
Maybe edit sketch or edit at the bottom, the timeline?
No, that's the sketch. I'm wondering, this is kind of an interesting question. How do I edit the sketch parameters?
There.
Go for the double click.
I'm trying that. That's not working either.
Do you have to go back to the original one?
Might have to redefine it.
How about if you right click on
that-
the event down in the lower left there in the timeline, right click on it, and then is there an edit? No, there's not.
No, because I haven't saved the sketch yet. That's
There's that comment that says create a selection set. That might be the one.
That might be it. Actually, let me try something. If I press and hold, nope, sketch line, parents, nope. There may be a way. It's not immediately obvious.
Hey, Tim, I'd like to point out that there's an indicator of how engaged your audience is, and you just got 20 different suggestions.
Love it. Oh, this is great. This is great. That's why it's a discussion group.
Yeah.
I like this approach.
This is the first one I've been on. It's wonderful.
Good. Welcome.
Yeah, welcome. Enjoy it. So those are the patterns. Project, include, we've covered a little bit in previous lessons. So basically, it's projecting lines from somewhere else onto a plane. So we don't have a good source here, except this object here, this rabbit text is somewhere else. And we can project lines from this guy. They might actually be in the same plane, but even if they weren't, it would project them onto this sketch. Yeah, they happen to be on the same plane because that's the sketch we did it on, or the plane we started with. But let's
to one of your datum planes, like your X, Y, or X, Y.
Yeah, let me, just for demo purposes, let's say I'm going to project this line here. Here it is on the sketch plane.
Oh.
It's driven by this. Now, if I include projection link, that link remains live and contains the history. And if I change this, so I'm going to say OK. If I, and I'm going to finish the sketch.
Do you remember which line it was?
It's this purple one.
Oh, okay, but that's the projection. Okay, yeah.
Yeah. And so now, if I come to this and I edit this 15 to be 5.
Okay.
Now when I come in, see the purple line has updated.
And that was because you kept a live link, is that what you said?
Yeah, if I kept a live link because when I did the projection, I specified that.
Yeah.
Now, if I were to do something like this again, let me hit P to project, and let me grab this line here. But this time I'm going to unselect projection link. Say OK. I'm going to finish my sketch. I'm going to edit my extrusion. And I'm going to change this to be, come on, baby.
Wasn't the arrow? What?
Oh, I meant to get the arrow, and I didn't. Instead, I changed the angle, which is interesting.
Yeah.
Let's make it 50. Say, OK. The fact that I changed the angle is going to make it crunch a bit more.
From what we can see, I'm not sure where the 50 went. What did you put it in?
The 50 went down to the lower right of my screen, but I put an angle on it, so it's doing some really wild things.
This looks more like my drawings.
Okay. But the key thing to note is, look at the blue line. It didn't change. The purple line did, but the blue one didn't.
Yeah, yeah.
Now what happened is I accidentally added 5 degrees to the extrusion of the text, so it all merged together, which is an element an item we want to get to in a bit here. Notice that a few things crashed down here. The highlighter in green tells me they've kind of crashed.
It's green on your screen?
Yeah, can you see the highlight, sort of yellowish green?
Yeah, yeah, okay, yellowish green, yeah.
Yeah.
Green weenie.
That's the technical name, yeah.
Which reminds me, I'm using a big screen. Is the text too small for people to see, or is this okay?
I don't know, legible to me.
Okay.
Let's see it.
Are the projection lines, are those real lines or are those construction lines?
The lines that are projected are real lines in Sketch.
What was the toggle? X?
It said projection link.
No, but if you were to make a line, a construction line, it was the X button?
Well, you can pick a line and when you're in sketch mode. Let me go back to this.
Click on a line and then hit X and it turns in.
That's what I'm trying to get at, yeah.
Click on a line, hit X,
There
yeah,
you go.
That's the short key.
Got it, that's all I was asking, thank you.
Yeah, repeat, yeah, so normal construction change. I usually find it in the menu. I try and, like I say, I'm trying to avoid learning too many of the shortcuts because
They'll lose us.
I'll lose you guys, yeah. And then dimensioning, we've gone over dimensioning before, so I don't think I'm going to go there.
Hey Tim, just out of curiosity, we are in sketch mode, and the icons we see on the toolbar range from line to square, etc., to dimension. Those are totally customizable by what you saw in the ellipses. So you could unselect to have the line show up in the toolbar in the create menu, right? So go back to.
Yeah. So for example, if I want polygon up there.
Yeah.
Well, actually, that doesn't have any ellipses, come to think of it.
Well, maybe it does in the submenu, though.
There, ellipse has an ellipsis.
Yeah.
I can pin this to toolbar and there it is.
Okay, great. Thank you.
Now, I'm assuming I can remove it by hitting reset. And I'm not sure if I can remove the default ones or not. I haven't actually tried that.
Like if you just go to line and see whether the ellipse is there. What does it say? Go to create menu and then line and see if there's an ellipse. Yeah, and see if you can uncheck it. Yep.
Oh yeah, there it is.
Boy, that's one you wouldn't want to do.
Yeah, not really. Generally one you use a lot. But how do I find the one that has?
Yeah. Up there it is. It showed up.
Oh,
You have to wait. So go over to the actual submenu.
Rectangle,
there it is.
An ellipse will appear.
Yeah.
There we go. There we go. Yeah.
Cool.
Okay. So yeah, you can customize your short keys up here, or your toolbars.
Tim, what are shortcuts that it refers to? Is that the keyboard shortcuts?
Yes.
I see. Okay, thank you.
Yeah, like L is for line.
Yeah.
Yeah. L for line, D for dimension.
And then they show up in the menu once you've defined it?
Yeah, there's some default ones in there, but if you add one, for example, if we go to ellipse, change keyboard shortcut, none's defined, let's go with E. Well, that conflicts with extrude. How about Shift E? That works.
Yeah.
Now I'll go up here. Now,
yep, sure enough.
That shows as Shift E.
That's great.
There's also the S, which is search, and if you just type S, it'll bring up like a blank menu. So type S, and then you can type like the A. It'll show you everything you could possibly want if you don't want to go through the menus.
Yep.
Yeah, if you forget where something is in the menu, this is a good tool. I haven't really used it much. I saw it the other day, but I haven't really used it much. Thanks for bringing that up.
Tim. Try this though. I tried to use this a few times to find the construction line key. Try construction. I couldn't figure out how to find that function.
Because we call it, oh no, because we call it normal / construction.
Yeah. I bet you if you did normal, it would probably show up. I just couldn't.
No, I guess the toggle isn't in there.
Yeah, so it's really useful, but it wasn't for that particular weird example, that's all.
Right. When you're in Sketches, there's a bunch of modification tools as well. You know, fillets, we know, trims, basically to the nearest boundary. So if something crosses something else, if I hit L for line and L for line and go across a bunch of existing lines. Now if I hit trim, it'll take whatever's between, or the end to the boundary. Sometimes it's easier to just show them than say what it is. Offset, we've previously used. You pick a shape, you can offset it, whether it's an open or closed shape. You can go in either direction.
Can you enter inches and decimal?
Yes. So you can enter when you're doing dimensions or when you're changing something. So for example, I guess I hit the
No, it's there. It's just on the right-hand side. I'm not sure. Can you drag it over?
Oh, I see. It went over there.
There you go.
Yeah, okay. So I'm going to do a line here. And then the default right now is set up as millimeters, but I'm going to say 0.24 inches. And it'll convert it to millimeters and put it in.
That's sweet.
But it won't give you the dimension in decimal inches.
It does there.
This is in millimeters.
Yeah, but underneath in the bubble that shows up.
Yeah, but in the bubble, yeah, that's right. Because now it's in the dimension table, which leads me to believe that when I go to the parameter table and I look at model parameters under Sketch 5, I'm going to see this one in here as 0.24 inches.
Sure enough.
Yeah, but I mean, if you want the dimensions to read out decimal inches, I guess you have to change the default to inches first?
Yes. So if I change the default to inches, now everything's going to show in inches.
Yeah, but will they show in decimal inches or Fractional inches. That's
They
what
always show, well, they'll show in decimal. Let me see.
You can try right-clicking on it, and it might allow you to change a specific instance into to show inches.
Well, does this give alternate dimensions if your default is millimeter and you want to have an alternate dimensions of decimal
In your drawing?
in your drawing?
That's a good question. I haven't tried it. Drawing packages that I'm used to do that. I haven't actually tried that. The drawing package is pretty primitive, I would say.
Okay, all right.
Could you dimension?
I'd be surprised if it does.
Could you dimension something now, and we'll see if it comes up in decimal inches or still fractional inches?
In design mode, it will always show you decimal inches. Decimal. Like if it'll do the same thing as, for example, let me do another line. I'm going to go like this, and I'm going to say 7/8. Okay, and there it is, 0.875. So it forces decimal inches. It will not, if I mouse over it, it'll show the fractional because that's how I entered it.
You can enter fractional too, right? 7/8.
That's what I just did, yeah.
Oh, I see, okay.
Yeah. So if I click on this to change it, and I say 3/4, it'll display it as 0.75.
Got it.
But when I mouse over it, it'll show the parameter definition, which was 3/4.
And for larger things, you can also dimension things in feet and inches. So you can do one single quote mark, space 5 double quote mark. Yeah, like that.
And then it should show it as 17.00.
Yeah,
right.
Yeah. Yeah, there's some neat stuff in there. We fill it, we got trim, we got extend, so you can extend a curve. Let's see, let's try extend on this guy here. Wait. Constraints, oh, that's because it's part of a, wait, no, this guy isn't part of the,
should be able to lengthen it, right?
should be able to extend it. Yeah, okay, extended.
Does extend basically mean you can move node points to make something either larger or shorter, but you have to do it by dragging a node?
I thought it would go to the nearest intersecting curve or boundary geometry.
Yeah,
it's kind of odd that it's not doing that when I'm in extend.
So you expect it to jump all the way to the next line?
It should jump all the way down to that blue line completely on the right.
Yeah.
I thought you created that line as an offset from one of the groups.
Okay.
Oh, he did, yeah.
That's why it's parallel to everything else.
Right.
So let's try a clean, fresh line.
Yeah, there's nothing like a clean, fresh line.
No, it's not doing it. That's
I think
weird.
what it's, I played with this a little bit, and I think what it's doing is it's picking the next thing in the X dimension or Y dimension that it lines up with. So any line to the left of that ends at a point, it'll extend it a little bit, and then it'll extend it a little bit.
Yeah, as represented by that red extension, huh?
Yeah.
Now it went to that line.
Now it did.
After all the other Y points that it aligned with.
So if you look at this one, you see where it's red. That's what it's going to extend to. And I'm guessing that that is the extension of this line here.
Yeah.
Yeah.
So that extension there is this extension here. Meanwhile, this extension here is a little line above it.
Wow.
So it's not an existing line. It's the extension of any existing line too. So that's kind of odd. That's interesting. I haven't really used that function here. Break kind of allows you to break something into two elements.
But is it only when it is already, say, a square with 4 corners and you're breaking an existing junction between 2 line segments?
I believe, let's see here, modify where it intersects other sketch entities. Okay, so let's do a circle there, and let's do a line through it. And now let's modify break right here.
Got it.
So this time it broke this guy.
Yep.
And I should be able to break this guy too. Now I broke him.
I thought it automatically did that even without invoking the break command. If you draw a line across the circle, then you can click on any part of that line, can't you?
Well, certainly on profiles, it will give you the partial profile. But see oops, let's go back one more. Now these are full lines. The entities remain full, but the areas, the profiles, it breaks. Which can be annoying if that's not what you wanted. If you wanted the whole circle, you have to select both now.
Oh, yeah, right.
You do an extrusion or something. Sketch scale allows you to sketch your geometry.
You mean scale your geometry?
Yeah, scale your sketch geometry.
Yeah.
Offset, we've done a few times tonight already. Move copy. You can just grab something and move it, which you can do anyways. You don't really need to be in the move copy menu. You can just grab things if they're.
But how did you invoke the copy function?
If you invoke the copy function, let's say move copy. Let's grab this guy, and we'll go in here and we will. Where's the?
There was a checkbox there before, I thought.
Where's the checkbox before? Or maybe because nothing's selected at the moment. Here we go. Create copy.
Yep.
And now you can move it down and have 2 of them. And you can specify dimensions and rotations. So you could do some fairly convoluted move copies if you like. And parameters we've talked about in previous classes. Valuable. Do lots of cool things with them. Generally the model parameters and the user, so favorites just gives you a way to find a quick shortcut to the parameters you're going to use more frequently if you have tons of parameters down below. User parameters, you can put in specific parameters and expressions.
How do you indicate any given parameter is considered a favorite?
When you create a parameter, we're going to put something in here that is box width, and we'll say it's 45, and we'll say okay. Once it's here,
the star.
You have the ability to put the star, and then it'll appear.
Okay.
Or if you, yeah. How are we doing on our time? Wow.
You're almost 2 hours in.
Didn't we? We didn't get that far. We talked about constraints before, so I won't go into great detail, but I do want to bop through a couple of the solid features here, because these were some key questions that came up. I'm going to, this sketch is kind of noisy. Let's just get rid of it. In theory.
It's still active. You've got to finish it.
Oh, I got to close the sketch?
All right, finish sketch. I was looking for the finish sketch button up here, and it wasn't there for some odd reason. Thanks. Now I can delete it. Okay. Any last questions on sketching?
Those four words there, it said solid surface, sheet metal, tools. That the sheet metal, it has to start after you've sketched something?
No. So what these are, so solid modeling is pretty much all we've been doing so far. And there's different kinds of ways of creating models. A surface model, you know, when we did a solid model, we had to have a closed section that we then extruded or revolved or swept. In surface models, they're not necessarily closed. So if we create a sketch, so I'm going to create a sketch here, and oops, let me go back to the solid menu. So I'm in sketch, finally, okay. I'm going to create, what is going on? Oh, here's sketch, sorry. I'm going to create a spline. I'm going to finish my sketch. And then in surface, I'm going to extrude this line. So now I have a surface. This surface has 0 mass and 0 thickness. But I can define surfaces, and surfaces are very flexible. There's lots of different things I can do with surfaces. And then I can use those surfaces to define solids in multiple ways as well. So one key thing I can do is I can thicken a surface, and now it's a solid. Right? And there can be some very complicated surfaces. And so products like plastic products that have lots of curvature and detail to them often initially get designed in surfaces. And the guys called industrial designers, these are people who do the artistic side of product design. They usually are surface modelers because they're looking at how things look on the outside. And then they'll create a surface model, throw it over the wall to the mechanical designers, mechanical engineers, and a person in that department will take it and turn it into a solid and make it moldable and all that kind of good stuff. So lots of things you can do with surfaces.
It just really creates the aesthetic of it, or the outer shape of things.
Correct. You typically build the outer shell with surfacing, and then either if it's a closed shell, you can solidify the whole thing, or you can add thickness to it like this. There's a number of different things you can do. So the surface menu looks a lot like the solids menu for creating features. Yeah. There are a couple of new ones like patch and offset and thicken. But fundamentally, if you extrude revolving, sweeping, lofting are all variants of extrusion. If you do it with a closed surface, it'll create a solid for you. If you do it with an open surface, an open line, open profile, you'll get a surface. Now you can do it with a closed profile and get a surface as well, but that's a special feature.
Tim, do you use the surface menu, or because of what you do, that would not be something that you spend much time on?
I do use the surface some. In particular, I'll import surfaces from other things and use it. Okay. I might import a surface from a part of an object and use it to match up to or work with. Or I might get surface models from an industrial designer.
Got it. Okay, thank you.
Or sometimes when I'm playing around, you'll see there's some tools that are kind of fun. Sheet metal is a different kind of thing, and that's basically, if you think about starting with a flat sheet of metal and cutting profiles and bending it in a tool called a brake or something like that, forming it, that's sheet metal. So it's a different design approach specific to how things get made in sheet metal. And you can create your object in 3D sheet metal and then say flat pattern, and it'll lay out a flat pattern showing the bends, etc. So here's an example. If you mouse over it, you'll see a junction box. And the junction box has a number of really cool features on it. It has mounting flanges. It has the shaped box itself. And it has what we call half shears, where you would punch out a cable entry. Well, you can design all that in 3D in the Sheetmetal, using Sheetmetal functions, and then flat pattern. And on the right of the pop-up, you'll see what the flat pattern would look like.
Tim, that's really interesting because it sounds as though they've taken the modeling capabilities and they've imposed a distinct set of constraints that relate directly to one particular process, which is making things from sheet metal. Is that what that?
That's correct. And it's interesting because it's kind of a blend between solid modeling and surface modeling.
Yeah.
But if you do, I've done a lot of sheet metal design in the distant past. And this functionality is, I mean, it's impossible really to do this well without these key sheet metal functions, because what it'll do even is you set up, there's a setup file with the parameters, and when you bend the metal, it stretches partly. And so it will adjust the flat pattern to account for that stretch.
Oh, wow.
So that your flat panel is correct. And then the shop can make a flat panel, cut it out using laser, water jet, or CNC punch, or whatever method they're using, and then form it into shape, and it should be dimensionally accurate.
Wow.
And do they give you the option of saying how thick the metal is and how elastic the metal is and that sort of thing?
That's part of the setup file. Yeah, that's part of the setup file.
Crazy.
I won't do anything with it today. It's a little more involved, but you know, it has a default of like 16th inch, I believe, or 1.6 millimeters sheet metal, which is a very common size. But you can go in and edit that and change it. One of the things I did want to, there were some specific questions earlier or last week to some features here. I think we all know extrude. We know what revolve is. We did an example of sweep. We did a closed sweep, but a sweep can be an open sweep as well. So you can see what pops up there. And there's some complications on sweep.
I'm sorry, the difference between revolve and sweep is revolve is around an axis and sweep is along an axis? Or a path, rather?
A path.
Yeah, okay.
So revolve is specifically circular around an axis.
Yeah.
But a sweep follows a path, which may or may not be circular.
Got it.
And within sweep, there's some things you can do. You can have the single path, which is, you know, we've seen some of that. Or you can use a guide rail. So that's when you use a path and a guide rail, two separate lines. And your profile can grow or shrink
Seriously? Oh
along the path, depending on how far away the guide rail is.
That's amazing.
Do that quickly. So let's start with a new drawing here.
What was that called again? What you're going to do?
I'm going to do a sweep using a guide rail.
Okay.
So I'm going to sketch first of all a line. So I'm going to go up with this line and an arc and another line. And then I'm also going to sketch
and that's the guide rail, right?
I'm going to use that as a guide rail in this case, yeah.
But right now they're just two sketches, right?
Correct.
Two lines in a sketch.
Two entities in the same sketch.
Yeah, okay.
So you're going to finish that sketch, and then I'm going to create another sketch on this plane, and let's make it, just for grins, an ellipse. And I'm going to go to this view because I want to be able to see what I'm doing here. Now I could go right on there, but I wouldn't necessarily have to, as we know, or do I? Let me think about this. I might have to actually. Let me do this. And I'm going to finish that sketch. Now, I'm not sure if all the appropriate assumptions have been made or not. I'm going to give this a try. I'm going to sweep. I'm going to use path and a guide rail. The profile is going to be this. The path is going to be this. And the guide rail is going to be this.
Oh my goodness. I want one of those.
So with very simple definition geometry, you can get some pretty complex shapes.
Yeah.
It's pretty squirrely there at the corner.
It does get pretty squirrely there at the corner. Now, the interesting thing, let's try and redefine this.
You've just defined a new hair dryer.
Dyson hair dryer. Yeah, that's what I was thinking.
So I'm going to try defining this is the path and this is the guide rail.
Yeah.
And I get something completely different. And the reason is because I'm going perpendicular to path. And the path is different. Now I could, I'm not sure what full extents is going to do. It's, yeah, do I scale it or do I stretch it?
And I think you can also get those lines and drag them right now and change the shape of the thing, right? I think you can. You can grab those points on the line and drag them.
Not while I'm in the, I wasn't able to do it within that menu, but if I come to the sketches and I turn on this sketch.
Yeah.
Oh my.
Right. Yeah.
Isn't that cool?
Yeah, amazing.
So basically a sweep is a profile going along a path, but we can modify it by using a rail. We're past our allotted time here, but if everybody's still awake, I just want to pop through a few more of these. Loft takes us, you have two profiles and it blends between the profiles. In this case, you're seeing a circle and a square. That's pretty straightforward. But if you go from entities that have different numbers of segments, it can get a little squirrely. It can twist on you in ways you don't really mean, and therefore you can do a few different things with loft. But you might have to go in and use rails. One popular...
You can use rails when you're lofting also?
Yes.
Wow.
As an additional constraint?
As an additional constraint, and in particular, when you're lofting something that has a lot of, especially if your loft sections have different numbers of elements.
Yeah.
You know, a triangle to a rectangle to a hexagon, for example.
Yeah.
You can use the rails to control what blends and what doesn't.
Right.
One classic example of a loft is, we've all seen wooden boat builders starting out with profiles along the boat. If you think of a canoe,
yeah,
or somebody had an Adirondack guide boat the other day on one of the discussions. So you can make those cross sections and then loft between them. Let's see if I have any showing here that I...
Thereby creating the unique shell of a given hull.
Correct.
Okay.
And lofting is often how you define a lot of, things like airfoils, aircraft shapes, car shapes. you can define it with multiple sections and loft them. You can imagine the nice swoopy curves of, say, a Corvette. You can think of all the sections along there that would drive that, that loft. Rib and web are two different ways of defining a strengthening feature. Whether you define it from above or from the side. A rib is from the side, a web is from above. These are things typically used in plastics to stiffen them up. You can use them in 3D printing, etc.
Except it's an infill for structural strength that you're doing from either above or the side. Is that
typically yes?
Rib.
Like a gusset. You know, they're showing a picture. They're showing a picture there of some kind of a plastic handle. That's looks like a box cutter handle.
Yeah.
And in that case, those webs are providing additional stiffening. Plus, they may also be locating the blade.
Yeah. Okay.
Now, those kinds of things. The hole functionality is interesting. We played around with it a little bit earlier, but you can specify all different kinds of holes. Simple holes, counter bore, counter sink, simple no thread, clearance hole, tapped, taper tapped, like a pipe thread. You can offset various kinds of threads, and then you can define whether it's a flat drill point or an angle drill point. And then all your parameters, there are standard threads, all different kinds of threads you can select and define on your hole as you place a hole.
No Whitworth, huh?
How's that?
I said no Whitworth threads.
I didn't look through the whole list, but yeah. There's a couple.
There are actually.
There's a couple of primitives that you can define. I mean, you can define you can sketch a rectangle and extrude it to make a box. Obviously, you can sketch a circle and extrude it to make a cylinder. But there's shortcuts to doing these kinds of things. Coil is kind of a fun one because you can define a coil, place the center point, find the outside. There's your coil. If you add an angle to it, let's make that 15, and let's go out further. You can see the kinds of things that you can do with.
Is it getting larger?
It's getting larger at 15 degrees.
Got it.
Becoming a tapered coil.
Correct. There, it makes it really obvious, 45. So you can do some fairly complex geometry fairly quickly. Pattern works similar to pattern in sketch mode and mirror. Thicken we did, and we're not going to go into the stuff down here today. One thing I'm going to show you, one last thing, and that is creating form, because that's really a surface modeling thing. But it's showing there's a lot of different things within form, and that's worth weeks on its own. But
what do you mean by form here?
Well, in this case, a form is
it's a lump that you can push and pull on and deform it.
A lump you can push or pull on. Okay.
So this is the equivalent of the box, but it's a surface feature, and you can now let's finish the form, and you can do weird things like actually let me show a more complex geometry. Let's do a more complicated form.
Yeah, just what my brain needed after 2 hours. Thank you.
Just about the time you ran out of scotch.
Beer's been empty for a half hour. Come on, man. Have some mercy.
Never run out of scotch.
It's like you're in your shop. You can get some rubbing alcohol.
Great. Sitting right there, 99%. Great.
Hey, I got to drop off to go to. Thanks so much. Talk to you later.
All
You
right.
bet. Thanks for dropping in. Yeah, there's a lot of different forms. With the forms, you can really manipulate them. I keep picking the wrong form, and it's really just growing. But you can push and pull almost like, think of it like modeling clay.
Yeah, like a model, a mold. Okay.
Yeah, like modeling clay, you can almost free form, make fairly complex shapes, and then turn them into solids.
I think you can also determine how many divisions there are on it, right? So how big a section you grab to pull out or whatever.
Let's try that. Let's go back to, let's do another, where are we? Come on. Let's create a, where were we? Form. Go into form mode. Let's do a cylinder. And to here, 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 here.
So there's a number of faces there.
Faces and height face, diameter faces and height faces, yeah. So let's go with the default. And now let's finish the form. Let's, oh, that's why. That's why. I've got to do it inside there. Instead of press pull, let's do this in the in modify.
Oh, so don't go to the solid or stay in the draw. There you go.
There you go.
That's what I've been trying to do.
And so you're still in form mode.
Still in form mode.
The equivalent of sketch when we're doing solids, right?
Kind of, yeah. It's a little different. It's its own kind of thing. But you see, you can quickly get into some very complex shapes. And one of the advantages is there's nicely smooth flowing surfaces in here. And when you build things with multiple features in solids modeling, it's hard not to get discontinuities. You know, you do something, if you have something that's squarish and you put a fillet on it, it's a discontinuity. You're going from a zero slope to a fixed positive slope rather than a smooth, gradual transition. And that's what some of the analyses, the curvature map analyses and things like that are for. If we, if we do an analysis on this, you see, there's some sharp changes here, but they're not as sharp as if you look at doing something on this body. These lines obviously are going to be extreme changes in.
How do we read this? Is it the more pastel is less stress?
There's no legend here, is there?
It looks like the reds are more strained and the greens are relaxed.
Yeah, but then the
looks
other
pretty relaxed.
The other shape is so pastel.
Bands, kind of giving us some idea there on that analysis. Gaussian, principal minimum.
Yeah, that's the one I was looking for, huh?
So you can quickly get into some fairly advanced shapes and functionality here. I had actually expected in 2 hours I'd get a lot further than I did.
That's amazing, though, man. That was amazing.
It's a good thing because a big part of that was the questions coming in, which I like dealing with the questions because it means that I'm actually talking about something that is relevant to people. So if you want another session at some point where we go through more of the menu and we do more different things, let me know.
Hey, Tim, why don't you do a vote inside of the client where you can give a reaction like thumbs up to the idea, that kind of a thing.
Yeah, I mean, do we want to go to?
Anybody else? Am I the only one who cares to give a thumbs up on that idea?
A few more. Okay, maybe I'll find a subject for next week, but then maybe in another couple weeks we'll do another one where we go more through some of the other solids features.
That'd be great.
And modifications. We didn't get to modifying solids at all.
Tim, personally, the reason this is so valuable to me is you sort of gloss over the items you don't use, and you don't necessarily force yourself to deal with what was that menu item that I've actually never used before. And by you revealing it, it allows me to say, oh, that's something I should know to use in the future. So,
and there's a whole bunch that you don't.
Yeah, well, that's true too. But at least I know to not use them. But right now I'm oblivious.
It reminds us how little we know.
Yeah, right.
I mean, for all of us, go to Excel and look at how many functions there are that you've never
Right.
used.
Right.
Well, I would like to take just a very simple, box, square, curve, toroid, whatever, and be able to take it from a design to possibly a 3D print or a CNC, and do the simple steps to take it the next phase beyond. Because some of these esoteric shapes I'm never going to do, or never going to use, or know where to use them. But I'm thinking more woodworking and how I can supplement my woodworking with kind of like the simple designs of what I want to do in wood or 3D print, and take it through those added steps.
Hey, Tim, just a thought on that. Just coincidentally, I don't see Mark Stuck on here, but he told me that he's really been doing that over and over again with all sorts of variations. You remember the note he sent us today about milling circles? And he still was like 1.17 inches off after he did his pre-finishing pass. He's been doing that kind of thing to go from Fusion 360 to his CNC and testing all those things. So, I mean, maybe you could get him to come in and do a portion of a session to answer questions like what Paul has about how do I get this from Fusion 360 to my CAM software to drive my CNC. And also Mark did confirm to me that the CNC portion to create the G code is not in the machining function. It stays outside of it and it remains available for the free user. So that was something we had heard differently from somebody.
Yeah, I think there's more than one way to create G code, and so one of them will be covered by paid extension, and maybe some of them are not.
Yeah, and the ones that we use, the Shapeoko, which is just the CNC that we use in the shop, apparently is not in the machine. So that means that we can all learn to use it if we use the CNC at the shop.
Oh, that's great. Well, yeah, because we had him do the 3D print demo a couple weeks ago.
Yeah.
And it'd be good to do another one. I mean, if you're talking about exporting objects for 3D printing, for example, this shape here, if we find it in the browser, it's body 11, we right click on it, we can save as STL.
And then it's just like everything else where your slicer is concerned with your current 3D printer.
Right, you just take it into your 3D printer and orient it, slice it, support it if need be, etc. That's the easy one there. But yeah, that's a good point, taking some of that through. That's going to be a common theme. I think that there's a couple of key areas I see that we haven't really delved into. One is physical material and appearances.
Yeah.
That might be a subject for next week.
And there was also the rendering, right? I know that's different from physical.
Yeah, I'm going to include that together with physical with appearance.
So I can tell people I made all these great things and I never have to show them the fact that I couldn't get it through the machining process.
Right. So, we take something like this and we say, let's just change the appearance in this case to wood, and we pick pine, and we just drag it over here onto this object, and boom, that surface is pine.
So it does it by surface, not by volume.
Well, this was a surface, extruded surface, right? So actually what I should have done is I think I hit the surface instead of the solid. If I hit the solid, remove the one applied to faces and apply it to the solid instead.
Got it. So it was dependent upon which surface you applied it to.
Yeah, in that case, normally once I've created a body from a surface, I'll turn the surface off. That's kind of weird because the surface is underneath in this case. That was, I got to play around with how it made that selection. There was also a question of, can I change the grain on the wood? I'm going to look into that. I don't have the answer on that yet. I think there's a way to do it.
I guess if we're talking about continued discussions, I experimented real brief with sharing a link and then being able to open that link and comment on or sketch on a response on a drawing and then send it back. But I never looked at what was sent back as a reply from, say, a potential client or someone that's kind of critiquing the work of what that resultant comments are in the drawing.
Yeah, I haven't done much with that. Like,
Tim?
Yeah.
My brain just melted.
Okay.
Is it same time next week?
Yeah.
Okay,
Same time next week.
Thank you, sir.
Tim, is there an email where I can email you with possibly a suggestion of a subject to cover?
Sure. Actually, the forum's a good place for that.
Forum? All right.
Or hey, hang on. Let me give you my email, and I'll put it into the chat window because it's commonly. Wait, let's see. I want to do to everyone. It's commonly misspelled, so.
Okay, I got it.
And then in the forums, we've got a lot of conversations going on in the forums. Oops. There's a lot of conversations going on in the forums, and one of them, at least one of them, is relevant to this topic of what do we want next. And I apologize for taking everybody like a half an hour overtime here.
No, it was interesting.
No problem. Well, thanks very much, Tim.
You're welcome, guys.
We'll see you next week.
You bet.
Thanks a lot.
Same time, same place.
Yep.
Thanks a lot.
You bet. Good night.
Right.
Good night.